buildings generate approximately 40% of all the greenhouse gases worldwide. And they are a big part of this whole green economy that we need to get into, and climate change. And I think people kind of tend to think, oh, it's cars, it's recycling, but buildings are actually a big contributor. So we have a group of architects and people in the field today who are going to talk to us about what we can do and how we can adapt our buildings to help our environment. And I don't know, I'm not sure a lot of people make that connection, but it's a really, really interesting connection to me. So first I'd like to introduce Paul Hutton. If Paul can wave over there, there he is. And he is with the Cuningham group out of Denver, an architect. And Kevin, Euronymous, did I get that right?
Yeah, thank you.
Pretty close, okay. And he is with SA&R Architects in Denver. And then Nicholas is back there. He's from AIA. And Jerry Johnson is not going to be introduced, but he's there. But he runs this whole show. So I'd like to welcome you all here and sit back. And I think we're just going to learn a whole bunch today. I think it'll be interesting. So
yeah, and just one quick note before we start the presentation. If you have any questions, feel free to write them in chat as soon as you think of them, and we'll be happy to get to them after. So you don't have to hold them till the end. Feel free to send that chat message. And if it makes sense, we'll answer them as we go, or we'll make sure we have time when we're finished.
Wonderful. Okay, well, take it away, and we're really excited to see what you have to show us.
Well, thanks very much for that wonderful introduction. And I'd like to say, since we have such a small, intimate audience today, I'd love to know more about those of you who've signed on. Could you tell us what brings you to this town hall today, and what might your interest be in this particular topic? Who'd like to go first? I see we've got a Gordon. Could you just tell us in a few seconds about yourself? We have time for this today. We usually don't.
Yeah. I have had a couple of homes built, I think are built to a very high standard for greenhouse gases, and it's something I've gotten very interested in because of that.
Great. Deborah, could you introduce yourself and your guest also?
Rich Farrington is my husband. He's the architect. Okay. And
we've
been
great.
really
Hello,
interested.
Glad to have you join us.
We've been really interested in climate change and what impacts we can have. So our daughter is also an architect in Denver.
Oh,
and we just recently built a home that we're at net zero. So we're really pleased, but we're also very interested in how other things, how other people can affect the built environment.
Great, thanks. And John Boyd.
Hi, I live in Durango, but I teach. Hey, Barbara. I teach for the University of Colorado at Denver in the business school. I teach a course on business and climate change, and so I am regularly trying to find more information to pass on to students.
Great. Well, we've got quite an expert audience, so I'm sure that the dialogue will be very high level. So with that, I'm going to jump right in. I'm going to share my screen. And
welcome to Mike Waldinger, also with AIA Colorado.
Right.
Hello.
And hello, Mike. And so is everybody saying a screen that's mostly green? Yes. Okay, good. That means I've got the right screen up. So our topic today, as you've already heard,
Paul, there were a couple other people that didn't get introduced.
Oh, okay. I didn't notice that. Well, yeah,
Olivia and Mike, and and I don't know Jerry, but anyway.
Go ahead. We got time, real quick.
My name's Olivia. I'm working with Barbara McLaughlin on her re-election campaign, and I'm excited to be here. I don't know very much about this at all, so thanks for partnering up with us.
Glad to do it. And who else? Did we have any others? Okay, hearing none, I'm going to move ahead. So you're seeing the screen, and the title right there is Decarbonizing the Built Environment. You've met me, Paul Hutton, and you'll get to hear from my associate and colleague, Kevin Euronymous, before long. So we're going to jump right in. So here we go. Of course, we're here representing the American Institute of Architects. If you don't know much about our organization, we're about 2,500 members who are resident and practicing here in the state of Colorado. And something I wanted to share with you is that our professional organization, the AIA, has recently committed and changed its code of ethics to directly address the issue of climate change and greenhouse gas emissions from the built environment. So this is something as architects that we take with utmost seriousness. We realize the incredible responsibility we have to work with our clients to design ever more responsibly. I'm not going to read these canons from the Code of Ethics to you. Just suffice it to say that it's even more important to us now than it ever has been. So something about architecture that you probably know a little bit about is this thing called building codes. The current code we all use across the country is this thing called IBC, which stands for International Building Code. And what I wanted to highlight for you was that it was only in 1975 that our building codes started to address and require architects to think about energy efficiency in their buildings. Before that, there were simply no standards at all on energy use in our buildings. And what's interesting to me and our profession is that in the last several years, the building codes have really started to push us toward higher and higher levels of efficiency. We get a new code every 3 years, and those codes are typically having a substantial impact on driving all buildings, not just for those who want to do more or better, but driving all buildings. And not to pick on Denver, Denver is just one example of many cities across the state of Colorado that have even pushed farther than the building code is requiring. So Denver's on track to hit what we call net zero energy. That is buildings that produce as much energy as they consume in a year in about 10 years. So that's pretty exciting. And again, other cities and municipalities are pursuing very similar paths. And we're really excited to see those municipalities take on this challenge. In fact, this is just a chart. And I'm sorry, I don't have too many charts. This is one of them that you'll see in here. And all this is telling us, this is tracking the evolution of the building codes and showing how Denver is on a path right now. So Denver is slightly ahead of that light green line. Denver is on a track, as I mentioned, to get to zero energy just about the year 2030. So that's pretty exciting for us, those of us who work in Denver and these other cities that are trying to achieve this. The general building codes probably aren't scheduled to get to net zero until the middle to late 2030s for comparison. Of course, you've heard about AIA, and so I just wanted to mention there are many other organizations and rating systems that we as architects deal with. Probably one of the most well-known ones is the LEED system that's put on by the U.S. Green Building Council, but there are many others now. When we do schools, it's CHIPS. When we're interested in health issues, it's often FitWell or WELL, and International Living Future is another one that we pay a lot of attention to. That one is about the living building standard, if you may have heard about that. So as architects, we apply these as it's appropriate, given the needs of our client and the project. So I wanted to share with you a project that's underway right now. This is a little bit further east of you. It's at Sierra Grande, so just your side of La Veta Pass. And the reason I wanted to share with you, this is our first large building in a very long time that is 100% electric. And it also is a building, it's funded by the BEST statewide program. And this is a building that within the existing construction budget, not as any extra add-on, has its own ground-mounted PV array. So this is a 90,000 square foot building that normally would be highly energy using, and in fact is highly energy efficient and will be net zero. In fact, it's designed with the standard we call passive house. And when we do passive house, it's an approach where we actually take dollars from the construction budget and invest more of them in a better, more highly insulated envelope. And as a result, we can simplify and reduce the cost of the necessary mechanical system. And that's why we can do an all-electric school in a situation like this, because normally an all-electric building would be very expensive to run. And one of the things that we're starting to do now is many of our projects, we do a full carbon model. This is something that's relatively new for us and most architects. So now not only are we modeling the greenhouse gas emissions or carbon due to the operations of the building, that's the natural gas, the electricity gets used, we're also starting to model this other thing called embodied carbon. And Kevin's going to take you into a little more depth on embodied carbon, but the simple explanation is that all the materials that it takes to put a building together, they have to be mined, forested, processed, extracted from the earth in some fashion and then processed, assembled, brought to the site, and finally put into place. That is actually a surprisingly large amount of embodied carbon. That's the term we use to describe all the carbon that's released all along the way to get the materials literally into the building. And so we're starting to model embodied carbon in our buildings. That pie chart you see on the top right, that's the embodied carbon. And you can see concrete is typically a very big proportion of embodied carbon, and metals tend to be a large one. This building, because it used a lot of wood for structure, actually didn't have so much. But a big push right now that you're going to hear about is how can we reduce concrete and steel in particular, or how can we find versions of those products that result in less carbon being emitted into the atmosphere. Closer to home, I wanted to share with you another project just completed 2 years ago now, just down the road from you, the Cortez Fire Department. This was their old fire department. And only 3 years ago, this was the main fire department building for the town of Cortez. Not very impressive building, is it? I hope you didn't think, by the way, that that was my design when you first saw it. So our design, the replacement building right next door to the old one, is right here. And I wanted to share with you because, first of all, we partnered with a local firm right there in Durango to put this building together. That was Mr. Rick Feeney, become a good friend of ours. And the south-facing roof that you're seeing right here over the residential portion of the fire station is ready to have a PV array installed on it. We're hoping that'll happen in the near future. And this is one of those buildings that's LEED Silver. And I wanted to mention the LEED Silver aspect because LEED Silver implies a certain minimum level of energy efficiency. And this building was required to be at least LEED Silver because there were DORA, state of Colorado, funds that were applied to the project. And DORA, by the way, has been a great supporter of energy efficient buildings. So it's a wonderful program that we're always excited to work with. I'd like to share with you another view. This is the interior of the fire station, fully daylighted. So even if there's a power outage, the firemen can do their job inside the space. It has these devices that we call tubular daylighting devices on the roof of this building. And just one more view. A lot of people say it's one of the nicest buildings in Cortez now. So we had a lot of fun working on that. Another organization I wanted to tell you about, I haven't mentioned yet, and it's in a way a subsidiary of the AIA, is something called Architecture 2030. And Architecture 2030 has been in place since the year 2006. And it essentially challenged architects to look at how much greenhouse gas emissions their buildings were responsible for, and to take steps so that every half decade we would reduce that energy use or carbon emissions by another 10%. So back in 2010, we were allowed to have a 60% reduction. Last year, we were at a 70% reduction, and this year we are at an 80% reduction. This is a voluntary compliance path that we have as a goal for every project. The truth is it's a pretty tough goal to get to, so only a few of our projects are making it, but we're making a lot of strides toward that progress. By the year 2025, we hope that the average of all our buildings will be 90% reduced. And finally, by 2030, will be 100% reduced. And by the way, the light blue band, that is the portion of energy use that we're going to replace with renewable energy. And one of the things we do as a design firm is that we model the energy use in every one of our new or addition projects. We calculate that out and we report it to a national database. And this is our annual report. This is what it looked like last year. You don't have to worry about how detailed it is. Just going to call your attention that that bar on the left that I'm highlighting, 49.9%, that was the average energy use reduction of our entire portfolio last year. So just about 50%. Remember, the target last year was 70%. So we were 20% behind, pretty good, but we're trying to do better. This year, of course, we're striving for 80%. So we have a lot of work to do. And we also collect data on a lot of our completed projects. That's this bar here, 78%. And we also have a target on how efficient lighting is. The term we use for measuring lighting efficiency is lighting power density. So I just wanted to give you a glimpse at the degree to which design firms are really digging in and understanding the performance of their buildings. This is something that's very important to us. One of the things that we do at Cuningham that's actually unusual is we've looked at our internal operations. I should mention we have 6 US offices, 2 overseas offices, 1 in Beijing that does the kind of crazy stuff you see behind me, and 1 in Doha. And we wanted to know what was our operational carbon footprint, not the impact of the buildings, but how we run our businesses. And so here's what we learned when we dug in for an entire year. We found that all the buildings and offices we occupy, that was only about 22% of our carbon footprint. Commuting, and these are estimates based on surveys, was another 17%. And transportation, especially air travel, because of how spread out our many offices are, air travel alone was more than half of our carbon footprint. Now, you could probably guess this year that's greatly reduced. I don't think that we've had any flights since March 13th. So we're probably going to be less than half of our former carbon footprint. But this is something that we're updating on an annual basis. And we have a goal of being 100% offset on our entire internal footprint by 2022. So just 15 months from now, we'll be a net zero firm. So Representative McLaughlin already tipped you off to the answer here. Normally, I like to ask my audience, if I were to ask you what sector of the economy, transportation, buildings, or industry is responsible for most greenhouse gases, what would you say? Of course, you already know, you had a clue, it's buildings. And that's a surprise to most people. They tend to think either transportation or industry somehow must be more impactful than buildings, but that's not the case. And so here's a few more charts I'm going to use to take you through this analysis. Now, when we look at building operations, that's just all the electricity, natural gas, propane, occasionally wood that we use to keep our buildings warm or cool and ventilated and lighted. That's not too much more than all of transportation. And you're looking at this big gray blob on the bottom of this pie chart in industry, and you see that's 43%. So you might say, wait a minute, did that previous slide, didn't you just tell us industry was not as much as building operations? But what we need to do is we need to break apart industry and see what's really going on in there. And when we do that, what we find out is that industry actually includes a tremendous amount of materials that go to nothing but construction. Concrete that I mentioned already, cement, steel, bricks, glass, aluminum, all those products that end up in our buildings are fully 11% of worldwide greenhouse gas emissions. So when I add that 11% to the 28% that is running the buildings, keeping them comfortable, that's where we get to that 39% that often we round up to an even 40%. So this is the pie chart that helps you understand. And this is global, by the way. The US tracks almost identically to this global picture. So I just wanted you to see that and have a mental image there. So now when we think about the built environment, and we think about where carbon is coming from, there are 3 big pieces. The first one is buildings that we're still designing and building between now and the next 10 to 20 years. The good news is we're getting pretty darn good at making those buildings more efficient. We already heard about a member of our audience who has a net zero energy house. Basically, their house, once built, isn't responsible for any greenhouse gas emissions, and we love that. We still do have a major problem to solve, though, in our existing buildings, because there is no mechanism by which we can automatically upgrade and therefore reduce the emissions coming from those existing buildings. And finally, as I've tipped you off, we now have this issue of the materials, construction, and infrastructure, all that embodied carbon. It's a relatively new concern for us designers that we've got to start tackling. So those are the 3 key areas of carbon that we're thinking about in the built environment. So I'm going to focus a little more on the material side. 3 key things that we can do much better with materials are first of all, we can reuse. And reuse can take many forms. The first thing is we can take old buildings and find ways to repurpose them and preserve them instead of just knocking them down or sending them to landfill. I know in Durango, you've got some great examples of buildings that have been adaptively reused through the years. I've had a chance to tour a couple of those, and I know you've got some great examples there. The next thing we can do is we can take local and recycled materials and find ways to put them back into new buildings. And finally, now that we're designing new buildings, we're starting to think, how can we as architects make these buildings easier to take apart and reuse the materials once they're done with that first useful life? How can we keep them upcycled instead of downcycled, or again, simply going to a landfill? So that's a key concept. In fact, one of the ways we're thinking about deconstruction is something we call a material passport that tracks the material fraction in a building, and essentially, just like a passport, tracks the presence of that material so that a municipality could know what is the inventory of materials that it has in its borders. The next strategy is to reduce. How can we, for example, design with less? How can we make our houses and our commercial buildings smaller and still have the same functionality? How can we take our urban areas, whether that's a town the size of Durango or a large city, and make it denser instead of sprawling out? Even when we're designing a building, how can we optimize the design of that building so it uses fewer pounds or tons of material? So these are all things that we're actively pursuing right now in order to reduce that embodied carbon. And finally, there's this whole notion of sequestering, something I find really exciting. So, for example, and you'll see a project that does this shortly, can we use wood in a sustainable way? Because wood is sequestering carbon. Can we embed it into our materials, into our buildings, and use it even as extensive amounts of structure? That's something you'll be hearing about. We're looking at ways that concrete sequester carbon within it. That's something pretty exciting. We're looking at a lot of biomaterials now. And finally, when we design the landscaping around our sites, how can we design landscaping that starts to sequester carbon? And by the way, a lot of typical landscaping, especially if it involves bluegrass, is actually a net emitter of carbon. You have to design a landscape very carefully so that it becomes a net absorber of carbon. And that's something that we're really starting to work with a lot more. And in fact, we have, as architects, targets now. You remember I had targets for the the operational carbon reductions in our buildings with that 2030 program. You might recall we're at 80% target reduction today. We have reduction targets already in place for embodied carbon in these materials. Right now, we're striving for 40%, which is ambitious admittedly. And you can see here's our timeline to get to zero by the year 2040, only 10 years after we get to zero on the operations side. And I wanted to share the state of Colorado is active in pursuing this objective. Only one other state has tackled this issue of carbon in embodied materials, and that was state of California. So there was a bill that got pretty far through the process last year before everything went on hold due to COVID, and we're assuming that it will be back this year, and we're excited to be looking at helping to craft that and support it again. But that bill that was Senate Bill 20-159 said that all the materials going into state-funded projects, we had to look at concrete, cement, steel rebar, glass, and mineral wool insulation. And all of those materials have to meet standards around embodied carbon for them to end up in state-funded projects. So pretty exciting development. And I think we'll see more and more municipalities and states and the federal government at certain levels take this issue into consideration. So with that, I think I am ready to turn it over to Kevin. Yes, I am. I'm going to stop sharing. And Kevin, if you want to take it away, I think looks like we are right on schedule.
Great. Thanks, Paul.
You bet.
So we should be looking at should have been looking at.
Looks good.
Yep, we're seeing it, Kevin.
There we go. Yeah. So thank you, Paul, and thank you for everyone attending, giving us part of your beautiful Sunday afternoon. We sure love talking about this. We've done it a few times around the state now with different projects, and it's been really interesting. John, thanks for the questions. If we can, I think I might roll through my presentation, and then we'll start to respond to these. So Paul, I was responding to a few questions in the chat while you were presenting, and maybe you can do the same too. John's got a couple of good ones up there.
I see that. Okay, I'll start looking at those. Thanks, Kevin.
Good. And, based on our audience, maybe this is preaching to the choir a little bit. Why are we looking at all of this? Our colleague, Deborah Lucking with Fentress Architects here in Denver, some of the slides that I'm presenting were from her presentation on a previous iteration of this, and she found this image that really struck her. This kind of looks like your night skies in Durango, perhaps, but this was actually right here in town in the early days of the lockdown. And it's hard to think of something beautiful coming from something so challenging, but that's very much what we see. And it was a powerful reminder to all of us of how much things could change, how quickly. And it gives us a lot of enthusiasm to continue trying to work towards this without a really bad reason to do so. But as Paul mentioned, I did take a little bit of time talking more in some more detail about embodied carbon and operational carbon. And both of those affect, of course, our clear skies, our breathing environment, certainly climate change and greenhouse gas emission from the 40% that we've been talking about is important. But there's a notion that, as Paul alluded to, we're spending more time looking at now. Over the last 20 years or more, energy modeling has gotten a lot more sophisticated. Design awareness of the impact of buildings stretches way back 50 years past this. And maybe sometimes we feel like shame on us as a profession for not doing this better. Each time we come up with a new technology that makes us kind of get around maybe designing the most intelligent building, I think we hurt ourselves a little bit in terms of how we build. But as we look at more now what we put into the buildings, it's also looking at what are those components, what's the cost in terms of carbon of extracting those, in addition to the operational component of the building. So this upfront embodied carbon, of course, is everything that it takes to get that material to a job site before it becomes a job site. And some of those are better or worse than others. We'll take a little bit of time looking at concrete and steel specifically. And Deborah had used this analogy to help people kind of get their arms around the embodied carbon versus operational carbon. A lot of people through the last 6 or 9 months have been spending more time at home doing kind of more traditional things like baking bread. And this one resonated with a few people. I think we can all understand a farmer's field, the irrigation, the fertilization, the harvesting of wheat, bringing that to a mill, grinding it, bringing it to packaging and flouring, delivering that to the store. You can kind of think of that as the embodied carbon component of that. And maybe the operational carbon component of that is actually turning on your oven or using your mixer or the lights and gas in your own home. It's kind of a handy way to think of it. And again, maybe this is a preaching to the choir, but beyond the energy aspects and some of the health aspects that John was asking about, really thinking about people, planet, and profit altogether, that we need to consider not just the first cost, which can be a problem with, say, developer-driven client sometimes, but the whole life cycle cost. What's the operational cost? And then look at those in a holistic manner, because I think what we find is a building, yes, can be more expensive to build in a really solid and enduring manner, but over the life of its use and reuse or dismantling, there's a lot bigger bottom line there. So that early to build expense often can result or should result in much less operating cost. And of course, there's social aspects to this as well. Whether it's health and productivity, which I think one of the questions in the chat mentioned, the most sustainable building, the most energy efficient building, if it does everything beautifully, but it isn't beautiful, is not going to be a sustainable project. If it's not a place that is enduring and that does take into consideration daylight, natural materials, biophilic design elements, then it's not going to be a successful building. And this can be seen in absenteeism, turnover, teacher retention, student test scores, mental well-being. As I think as we head into another winter of being indoors a lot more, that's going to be more and more important. And of course, I think underscoring what this does for the planet is being covered in a lot of different ways through this presentation. So Paul mentioned before some of the things that we are measuring, probably more than we used to, certainly the life cycle costing that I just mentioned. That whole assessment of not just the dollars, but the impact beyond that. And then looking at this list of embodied emissions, whether that's extraction, transportation, manufacturing, and then what happens to it all at the end. Not a lot of high-rise office buildings in Durango, I know, but somebody, Deborah, had this slide from a previous presentation that just looked at what is that embodied and operational carbon and how is it allocated around the building. And that operational carbon is a much smaller portion of it than perhaps the structural portion. And that depends again on if it's concrete or steel. And I don't believe I have the images in this presentation, but as we talk about the mass timber buildings, we'll look at one of those. We're seeing some interesting things happen within the building code that are allowing for taller and taller wood buildings. And of course, that has its benefits in the characteristics of wood being a renewable resource and being so darn good at sequestering carbon. One of the other things that we talk about a lot, and I mentioned in the chat before, the International Living Future Institute is a group that we'll spend a little bit of time on today. There's this notion that transparency leads to transformation. And we all probably look at the nutrition label when we pick up a loaf of bread or a bag of chips or something like that. And the notion that knowing what is in that product guides you hopefully to make a better choice and put down the bag of chips perhaps and get some vegetables. That notion has transferred now to the building industry in a couple of ways. This environmental product declaration, this EPD, is something that we're seeing more and more of in a few venues, and it's looking more at sort of an ingredients list for your building. And the JUST label is a similar thing with the International Living Future that actually looks at the the social component of your firms as well. So what's your gender equity? What's your pay equity? How do you support your community that you're in? Those lead to a healthy organization, just the way that the materials we select can lead to a healthier building and less impact in the long run. So this was the small analysis I mentioned between concrete and steel, and it just, as we dive into the materials, maybe makes us think about those materials in a different way. Concrete, of course, is a centuries-old material. The Romans used this, and it is still active and standing today. Sort of a technology that was forgotten for an awful long time, and reinvented, I guess, or refound, somewhere around the late 1800s, and has certainly been evolved in its makeup, composition, different means of strengthening it, and how we use it together. And of course, steel has the properties of being able to perform wonderfully in tension, very good for long spans. Both of these materials do have a substantial cost in terms of extraction. So when we look at those carbon impacts of concrete, there's the getting this stuff out of the ground. Of course, as you make concrete, the cement component of concrete, the cement is the binding agent within concrete, is very energy intensive. It's a firing process, it's a chemical reaction, and that of course creates its emissions of its own, mixing that as well. And then of course the transit to a site, how it gets used, and then what happens to it at the end of its life. So concrete is a little less apt to be reused depending on the form that it was installed in. Sometimes it can be that, like a precast building, the old, the T-planks that you see, they can be reused. But a lot of times a building that's concrete frame is generally demolished, and some of that can be diverted back into new aggregate or base or reuse. And then steel, of course, again, the extraction process for the materials is very intensive, very disruptive to the environment. And it too goes through this firing process. So this basic oxygen furnace that puts these things in together, creates the iron ore that's extruded through. And then you have similar issues of transit and how it's used. You will see that there can be better opportunity for recycled content in steel, and sometimes it has a better chance at the end of its life cycle to be reused. And that's illustrated in this side pretty well, that concrete, some of it can be recycled, or downcycled a pretty good portion of it with a mindful contractor and owner. Timber, depending on the form that it takes, can also wind up a lot of it going to the landfill. And then steel, despite that very intensive early process of extraction, has a better possibility for reuse. So these are all things that we weigh when we're looking through our material options in designing a building. And then there's all the other factors that go into it. How big does it need to be? How tall does it need to be? What are the spanning requirements, and all of those notions. So we'd like to talk a little bit about some examples, both near and far, that have varying degrees. None of these will be, well, with a few exceptions, these are not net zero buildings, but they focus on different aspects of the larger issue. And some of them actually will respond to the questions that were asked. And then I think I have a few that aren't even on this cover slide that we'll go through as well, that are more local to Southwest Colorado. And actually, we'll start with one. We have two that focus on reuse, and the embodied carbon that goes into a project at its creation, especially when it's a long-standing old building. There's tremendous value in that in terms of the environment and also the character and the history, the cultural connection of a place. This is Mount St. Gertrude's Academy in Boulder, now called the Academy, which was first built way out in a hill near Chautauqua Park, near the Flatirons, and fell into disrepair, was used by the university, had a pretty bad fire. And I want to talk a little bit about this and the characteristic of owners, because I think John asked this question about what are some things we can do to incentivize people. Hopefully it's not that a fire burns down the building and you have to reconsider the systems completely. But even with that case of what happened with the main structure here, there's a real dedication required from the client, the owner, and the owner and client that did this project over 20 years ago still operates it. That there's some vision, there's some grit and determination that's going to be required to resurrect a project like this. We'll look at something closer to home that looks at that adaptive reuse. But if you picture, especially this building being built in the 1800s, what was the manpower, the horsepower, the extraction to get this to material on site, and what's the value of it remaining there rather than being torn down, even after an unfortunate fire, to being reused again. And this one is similar, and this speaks again to the client type. So the client in this case is GSA, the Government Services Administration, and this is a building right near downtown Denver. You can see it off the skyline off to the left there. And this is a unique example of an adaptive reuse for several reasons. Maybe the most notable from the contractor's point of view and the occupant's point of view was this entire building was reskinned while it was actively being used, while it was being occupied. And I recall seeing some, chatter about it of, couldn't they build the building a little bit better? This was probably a building built in, I think, the 80s. So there was some criticism of, why was that such a, why did they do such a poor job with that building to begin with, that they needed to pull the whole skin off. And I don't think it was a particularly poor building for its time. But really it was, whoops, I skipped ahead there. Government Services Administration, the GSA, are data junkies. They love to analyze cost, performance. They have metrics on so many components. So somebody in probably a cubicle in a very not well lit office somewhere ran the numbers on this building, and they said, rather than tearing this building down and building a new one, or trying to change out just the glazing and getting a marginal return, they literally removed the entirety of the skin of the building and put in a higher performing, better insulated skin with better performing glass. And to be able to do that during occupancy really takes that commitment I mentioned from the owner to understand this building will use less energy if we do this. It's going to extend its lifespan. We're going to keep the benefit of the concrete frame of the building rather than losing that component. And And then they added this solar, photovoltaic solar array, which is quite prominent from the bike path that's just below the screen here. And anywhere you drive by on Spear Boulevard here in Denver, as a kind of a visible and artistic element of renewable being a component of that smarter reuse of the building. And then another building that kind of teaches closer to home here, this is a rendering, but the building is now complete from our friends at Stantec Architecture, is the Denver Water Center. And we like this building for a few reasons, not only because of its energy efficiency goals, its mindfulness about operational and embodied carbon, but the notion that they run the water for Denver and the surrounding regions. And the notion that they can make this building approach net zero from a water use point of view is a real commitment. Again, it speaks again to that commitment of a client, of the mindset of going into a project saying, how can we do this not just the same old way? So whether that's gray water reuse, collecting rainwater, basically creating a water treatment plant of its own within its own facilities and having a bit of a closed loop to that water cycle system. And then going the step farther to actually educate the public about that. So wherever those elements exist in the building, it's set up very well to accommodate tours for people to understand and see, probably not quite touch, but see the systems of it works, and reconsidering a building as a system rather than just a container of people and things. And then I mentioned mass timber a little while ago. This is a project of ours in our office. We're partnered with Lake Flato out of Texas, down at DU, Denver University. And this is a student achievement center, basically a career connectivity to the professions the students are growing into, and a resource component, very critical piece of their quad as they're going through a lot of building down on that campus. But one of the advantages, or one of the unique things about this structure, and I've deliberately used the photos in construction because they're pretty compelling, is the utilization of this mass timber approach, which is an acronym called CLT, cross-laminated timber. And what this does is it uses the materials from really younger growth trees, so certainly last, usually about 10 to 15 years, that can be sustainably forested and actually contribute in thinning forests out to avoid some of the wildfire considerations that you have with forest management. But it takes, instead of, you might see this if I was downtown at my office right now, I sometimes point up to the ceiling. It's a big old warehouse building with giant wood beams in it. Those trees, of course, would be a tremendous loss if you're taking down old growth forest. We've done too much of that. We kind of screwed it up on the first go around, and we can't do that anymore. But this allows us to build in a similar way with smaller components of wood that actually become stronger because of the way they're cross-laminated. So if you can think of, one layer going like this and the other layer going like this on top of it, sometimes 3 or 5 or 7 times over, those constituent components of smaller wood actually strengthen each other because they're working in different directions. So what's the benefit of that? Several. Of course, the carbon sequestration of wood, we mentioned that trees do a really good job of sequestering carbon. This building alone, I think somebody was running the analysis of, what's the equivalent cars per year that takes off of the road, both in terms of, mostly in that case, in embodied carbon. And then when you make decisions like that about the structure of the building, again, a committed client, they're probably going to be a lot more focused on the energy use and putting more quality skin on. There's, of course, a photovoltaic array. This will be a LEED Platinum certified project. And we've mentioned LEED a few times. I think maybe most people know about that, but this leader in energy and environmental design, and it has ratings from certified silver, gold, and platinum being the highest. And then some of the health aspects about this building, of course, daylight views, but I mentioned before biophilic design, which is this notion that a connection to the materials in our natural and built environment has been proven to be beneficial for our health. And I think it helps in understanding of you look at a column or a beam and you understand what that thing is made of and how it's supporting and sheltering you. So closer to home, for the city of Durango, and I pulled up this Google Earth image because it highlights something important about growth too, especially in an environment like Durango. There's probably more impetus for us to reuse existing structures between the river to the west, Fort Lewis College up on the hill, mountain ranges all around it. We haven't the opportunity, thankfully, to just keep sprawling out into greenfield developments. So as we go through, that gives us the opportunity to look at existing building stock and this neighboring community in Silverton, reconsider the craft, material, and quality of buildings of 100 years ago or older or more recent. So Representative McLaughlin asked before about this project, which is highlighted in one of our previous conversations, completed by our colleagues at Anderson Hollis Architects in Golden, Colorado. And there was, again, a real commitment to the quality of this building, the value of it from its culture, its history, but also going through and looking, taking a real look at how this building was made and performed. The notion that there was coal-fired heating in a student environment is a little amazing, but it worked for a long time, but there's a way to make that building perform better. Certainly in preservation cases, the authenticity of the openings, the windows themselves becomes a big area of concern. And another thing to note about this is, and I don't have Brandon's notes current on this slide, but there are a lot of different funding aspects that go into this. So good intentions and good clients are all necessary, but they don't always pay the bill for this kind of careful rework. So this is probably a best grant. I think Brandon mentioned a few others that I can look up after I flip off the presentation. But reconsidering a building holistically, go through its systems, go through its enclosure, and understand how those components can be improved and sustained for the next generation. I'll move on through a few others. This one Brandon had in his, I didn't learn much about this, but up to the north a little ways, a new project planned also by Anderson Hollis. And I wanted to highlight one component of this EUI, this energy use intensity. I mentioned before the transparency leading to transformation and the kind of the nutrition label or the material label for your buildings. This is a similar idea. Think of your MPG, your miles per gallon for your car. The energy use intensity is really, it's your kBTUs, kilowatt British thermal units per square foot per hour that you use. So it's just a way to look at this. And 25 for a library is really quite low. It's a very aggressive target. You might find a similarly constructed building that wasn't so mindful and didn't employ some of these strategies be as much as 3 or 4 times higher that in terms of how much energy it uses. The other component to all of this when we talk about embodied carbon and operational carbon is doing the best we can with the envelope is really the first step. On-site renewables really aren't there yet to get us past a poorly performing envelope. So orientation is critical, insulation is critical. We need to get the building to do as well as it can. Paul mentioned the passive house strategies on the one school. We need the buildings to do as much as they can and then make up what we can't with renewables. And then also in the south part of the state, I was looking around a little bit for some images closer to home and wanted to talk about that structural frame issue. So as we go from very large concrete building scale to smaller scale things, for instance, in a residential market, straw bale construction is a consideration for small and large buildings. And I thought this was a really lovely example from nearby. Getliff Architecture is a Boulder-based firm, but they came up with this beautiful building down in Crestone, and you get a sense of how those mass heavy walls are built out of straw bales through there. And I think I have another construction example. So this is also in the southwest corner of the Four Corners area at Bluff, Utah. Design Build Bluff is a program where students from the University of Utah and the University of Colorado combine efforts to design in one semester a building, a house, and then they actually go out and build it. So it's a design build program. And Rick Sommerfeld is the contact that we know on the Denver side of this, the Colorado side of this. All of these buildings are incredibly thoughtfully sited. They're usually very energy efficient. And I highlighted this one for its use of this thing called SIPS panels, which is a structural insulated panel that you can see this gentleman standing up. This isn't from this project, but it allows you to put together a very well insulated wall and also eases the speed of construction. That's another component of the CLT buildings I mentioned before, is these pieces that come in as built pieces are quicker to assemble than individual sticks and then layers on top of those. And then this may be one of the last elements I have closer to home. Again, a LEED Platinum Visitor Center at the Mesa Verde. And I believe I have the wrong notes next to that, but they're close by. And I think it's just nice to know buildings that are close to home. I've been to this building and I know it has a pretty good explanation and some truth windows, like little openings in the wall where you can see how the building was constructed. And it ties together a number of things that are, the cultural aspects of that place as well as the performance aspects. Lastly, we talked about some LEED Platinum buildings. A number of years ago, about 15 years ago, somebody asked, what could we do that's better than LEED Platinum? And came up with this metric called the Living Building Challenge. And what you see here is a sort of an ascension from a zero carbon building to a zero energy building to something that's called CORE certified or a PETAL certification. And a full living building certification is really, remarkably difficult to achieve. The Living Building Challenge is called that for a good reason. It is challenging to do this. It effectively takes this notion of making buildings, going from making buildings less bad to asking the question of what does good look like? How can a building be more like a plant or a flower? That's where the petals graphic comes from. Not only be beautiful, but be of its place and be regenerative to its environment rather than extractive. And this isn't just pie in the sky thinking. At this, at the time this slide was put together, there were 115 certified projects around the world, and many more underway. In fact, here in Colorado, at the top of Pikes Peak, 14,000 and many feet above sea level, the new visitor center that's being built there is a Living Building Challenge building. And it's a remarkable environment. Being Coloradans, I'm sure a few of us have been at the top of a 14er in some pretty difficult conditions, and to conceive of a building that can be self-sustaining on its own in that environment is really remarkable. That's from our friends at RTA Architects in Colorado Springs. So I think we're okay on time for a few more questions, and we can certainly dwell a little bit longer afterwards. But I think as we close, it's, what we really hope to do this was just help people understand the impacts and potential of our built environment. And raise that awareness, ask us all to ask questions of the people that help define our built environment, whether that's the architect or the general contractor or your municipality or a college, or maybe you're doing an office refit or you're considering something for your own home, to really dive into it more and ask your architect. And if you're not working with an architect, certainly we'd encourage you to do that, but also, to be advocates for your own space and your own environment. So I'd like to say thanks again to everyone that joined, and to Representative McLaughlin for putting this on. We'll open it up for questions.
Did everybody get their questions answered in the chat that they wanted? Were there someone, I guess we can start. John Bird, did you get your questions answered, or there's something you'd like to ask again? John here still?
Yeah, I am, Barbara. Yeah, I'm doing fine. In fact, I need to go. Time for dinner. Thank you all. That was really interesting.
Thank you, John.
Nice job.
Bye-bye.
Let's see.
There were
Somebody.
some great questions in there. It was fun to try to respond, but I'm sure there are some follow-up people might like to engage in.
Yeah, Deborah, how about you? You had a couple of really interesting questions. What did you get yours answered? Yeah. You have to take off mute.
Yes,
Yeah.
thank you. I don't know if I wasn't looking through all these answers, so I don't know if you've answered it or not.
Go ahead and ask again, that's fine.
The concern I have is that my brother-in-law does a real estate development in Denver, and he's hard to convince that climate change is important, or how do you get the bankers or the investors to invest the money to make an energy efficient building. And I'm just interested, you know, you had those 3 Venn diagrams of profit and people, and and profit is the only thing that real estate developers, I think, are used to thinking about. Do you have any ideas about how you motivate? I mean, you did answer this thing about transparency, but how do you get real estate developers to think about climate?
Well, you know, my first response is always, that's where the building code becomes so important, and why I shared that constant progression. So I feel like as advocates at AIA, we need to work hard to encourage municipalities to always be adopting the most recent code and to keep up with those codes. And Kevin, didn't you say that is Durango on 2015 right now?
It is, yeah.
So Durango needs to get with it. Durango should already be on 2018. There's no excuse not to be, because the 2021 code comes out next year and it needs to be adopted by 22. That's just a great example. And the challenge we have here in Colorado is one of the few states that's a home rule state. So there is no ability for the state to say all municipalities must use the most recent code. Municipalities get to make that decision on their own. And besides making it really complicated for architects, because we're maybe using 4 or 5 different codes on different projects as we go around the state, it means that it's possible to be 10 or 15, even 20% behind on today's current thinking around efficiency. So it starts by raising the floor, making it impossible to do worse than a certain minimum. And once we've got that in place, then we want to look at, okay, how do we keep raising that ceiling? How do we encourage others? Now, we do have developers, and we work with a lot of developers. Some of them take that attitude you described, but we're finding more and more are finding that, especially on the financing side, there are incentives to go high performance. So we have one housing developer. Housing can be a really tough market, but this developer tells us, you know, if I've got LEED Gold and I know my financing is going to be secure, and it makes a better project for me. So I do find that there are developers who get it and are increasingly getting on board with this. But you're right, it's a tough one to crack, some of those developers. And you can't use payback, return on investment, because often they're selling the building before it's even complete.
Yes, exactly the
So
problem.
there is no argument around return on investment there. So you have to look for other incentives. I'll just share with you one other incentive and then look for Kevin to share his answer. And that is, we are seeing municipalities starting to put into place. We've got a housing project going up in Lakewood right now. That developer was able to get an extra floor on the project in exchange for guaranteeing that they would go LEED Gold, and therefore the energy efficiency that went with that. So we are starting to see some other incentives out there, voluntary, but they can motivate. City of Denver right now does have a program in place where they're letting pilot programs half the permitting time. So every review is 1/2 the normal time if you follow their new green stretch code. So those are some of the things we're seeing.
Thank you so much. Those are great ideas.
And I think
I actually have a question about mass timber. CLT uses a lot of wood, and we have a lot of pressure on our forests and harvesting of wood. And I understood what Kevin said about using smaller trees, which then gets to how do you harvest and do you get, how do you control harvesting the forests so that you get the smaller trees so that you don't put undue pressure on our national forests? It just seems like those are working in opposition.
Yeah, it's a great question. Thank you. So the harder part of it, actually, the news is worse in terms of how this actually happens for some of these projects, because currently the people that are most doing, the engineering, milling, and fabrication of the cross timber, the cross-laminated timber. There's not a lot of it local in the States. Now that's changing. There's actually an article in the Denver Post just this morning about new facilities coming around. But as this technology comes more prevalent in the States, what's unfortunate is about some of the first projects, including the DU one that I showed, that came from Quebec. So it's sustainably forested in Quebec. They actually have their own forest and they manage their own growth and replanting and production. But the operational carbon of getting that from Quebec to here, of course, it's going on a truck, right? And a lot of trucks to get across the country. The other prominent manufacturers are from Germany. So then it's going, it's getting shipped, which is not great. So it's a drawback to it. But one of the things that they, and I don't know the numbers for this, some of the responses I've seen to that question have been, they measure in hours how much forest growth a building took to get there. So they're looking at their forests from which they're extracting this material very carefully. And something I think that, I don't want to quote it for certain, but I think there was something like 47 hours of forest growth in that Burwell Center. So you're still cutting it down probably with a gas powered chainsaw. You are milling it still, so there is cost to that. But I think the long-term analysis of that has to do with, you're going to have some of that extraction and milling cost in any material you use, using the tree that sequesters carbon so well far outweighs the other costs of that.
Yeah, the last conference I was able to attend in person was back on March 8th in LA. It was the Carbon Summit. And one of the things I heard that really surprised me was an estimate. This came from forestry folks, that we could double the amount of lumber being used in North America and still not negatively impact the forest through proper forest management. Now, I'm not sure I completely believe that, but that came from someone who didn't seem like they were ruthlessly cutting down old growth. And when we use these CLTs in wood projects, we want to be very careful to specify a chain of custody for that wood. So typically we can use the Forestry Stewardship Council, or FSC, product. So, I think it's an emerging issue. Whether that fact that I heard and just shared is accurate, I'd like to do some more research and find out. But I think Kevin's right in it. When you look at the total picture, lumber creatively used is so much less damaging than the options of steel and concrete, that there's a lot of incentive for us to pursue this and understand it better. So
yeah, and part of it too, I'll just echo that, it is an emerging product being used in the way it's starting to be used. And so as more jurisdictions get comfortable with the product being used in buildings, as more architects and engineers get comfortable designing around it, that will impact the way it is grown. And so as the market matures, you will have the producers responding to how to meet demand, but meet demand over the long term. And Paul's absolutely right. FSC certification is a great thing right now, knowing that a forester is already thinking about that. But as it gets more popular, there will be more opportunities to kind of standardize how it gets harvested. And I think long term, that's going to be a better solution than relying so much on concrete and steel.
Yeah, I think global supply chains are also an issue here. On our home here, we used a heat-treated wood product for the decking. So I almost didn't do it because the wood was harvested, I think, in New Zealand, but the only heat treating process was in Belgium, and then it's used in the United States.
So it had to go halfway across the world. Yeah,
it's ridiculous.
Yeah,
and I suppose once these technologies mature and the demands are high enough in this country, then we'll harvest it here and we'll have it heat treated here, and then it'll make more sense. But in the beginning, with new products, sometimes it gets pretty crazy.
That's what's exciting about all the ability that's becoming new to start measuring the embodied carbon in materials, so we can kind of evaluate, is, you know, sustainably harvested and manufactured wood from halfway across the country going to be better for a project in Colorado than steel made in Durango? You know, from an embodied carbon standpoint, you know, that steel might make more sense for certain projects in certain places in the state. And so we're kind of on the cusp of really being able to start measuring that embodied carbon for those major building products on more and more buildings to really be able to say with confidence, this material is the right product for this project, and then back it up with numbers. So that's an exciting evolution that we're kind of on the cusp of.
You didn't know your deck would come with its own passport.
Yeah.
And I'm all concerned with this because
I want you to look on the screen and meet Mike Waldinger. Wave, Mike.
Hey, Mike.
Mike is the CEO of AIA Colorado, and we gave him an opportunity to introduce himself at the beginning, but I think he probably didn't hear or understand what we were requesting. But Paul and Kevin and Nick and Mike probably will become regular fixtures at the Capitol. And Senate Bill 159, which Paul mentioned earlier, was carried by Senator Chris Hansen. We had the votes in the Senate, but then of course we had the pause because of COVID, but I'm confident it will come back next year. So we'll be talking to you more about that.
And I think the benchmarking bill, Jerry, too, you know, we in the chat that was mentioned, it didn't come up here, but a way to deal with existing buildings is a robust benchmarking program that came up last year, didn't get very far, but I'm hoping we can work to refine that and see if it might have some life this coming year.
And Barbara, Kathy Kipp from Fort Collins is carrying that bill.
Okay. I'll talk to her about that.
Yeah, we'd love to see a good version of that come forward.
I have kind of two questions that are a little offside. One is COVID. I think we need to start addressing when we're redoing buildings to make sure that maybe windows open, something silly like that. And I know you have a lot of those on your buildings that you were showing us. So I'm kind of wondering if that's being incorporated into new buildings. And also when we hear about how China's not taking any of our recyclables anymore and they're just kind of adding up. Are we looking kind of more intently about how to reuse those recyclables? I would rather people stopped using plastic altogether, but I don't think they will for a while.
Well, I think we need 2 more hours to address the questions. They're such great questions. I want to tackle the last one first. So the whole material thing is just an enormous issue, and how we think about and deal with materials. Now, just beyond construction, just all the materials that enter our daily lives and consumer products and everything else. It's something that is ripe for change, and it desperately needs to be changed. Boulder, for example, has just started a program that they call the circular economy. Circular economy is a movement around the world that we're starting to participate in. And so Boulder has basically done an inflow-outflow analysis of every pound of every material that crosses its borders. And that's where the material passport thing comes from. So, for example, every building would have a material passport, but they're also analyzing the entire inflow-outflow of materials. And Boulder has done a pretty good job of things like recycling and composting in the past, probably the best in the state. But even so, and here we are, Colorado, we're at 18% average recycling today, in the bottom 10 in the US, partly because we're kind of a spread out population, like you understand that with Durango. It's so hard to develop the infrastructure in a state like ours to accept, reuse, and process, and then find new homes for these materials. What the big trend that I'm seeing is the problem with recycling is all the pressure, all the responsibility has been on consumers, all of us in our homes and businesses, to figure out how to separate, what bin does it go on. It drives us all crazy. What we're going to see in the near future is a reversal of that. The pressure needs to be put on manufacturers to make it so that their products and the packaging and their products is easily recyclable, easily separated, doesn't commingle materials that make it impossible to do anything with when you are done with that product or when you open that package. So this is unfortunately a policy issue. But we are starting to see efforts around the world. There's a 5-city consortium in the European Union that's tackling this really aggressively. And so we've been tracking some of the efforts there. It's Rotterdam, Amsterdam, Copenhagen, like you'd expect, London and Hamburg. And so we are seeing cities really take this seriously. So that's kind of my response to that one. And again, we could spend an hour or two. In fact, I was running a webinar on that just last week. But the issue that I'm really interested in too is the whole COVID thing. And you're right, there have been 2 recommendations that have come out from WHO, from CDC, from ASHRAE. Everybody says, if you have windows, open them. If you can increase airflow, do it. And if you can improve your filters, do that too. And what we're finding is we have worked closely with a few school districts, some of them quite large with 70 buildings or more, is that few of them have operable windows that they can't open. And a lot of them had operable windows that they permanently shut years ago, and they're running around trying to open them. And, we can do natural ventilated buildings here in Colorado. We can do it much of the year. Typically, we find it's around 40% to 50% of the occupied time. I can actually have natural ventilation in place, but then at a certain point, it's going to get too cold or too hot, and I'm going to have to close those and depend on some mechanical ventilation. So eventually the opening window thing falls apart just due to climate reasons. And once we're in that mechanically ventilated mode, we have to find ways to do that better. And what I try to explain briefly in the chat is that as architects, we don't have standards around ventilation. We rely on the mechanical engineering community and their professional organizations, in particular this thing called ASHRAE. And what we're finding is that the ASHRAE standard has been interpreted really loosely and has frankly resulted in buildings being under ventilated for the last 20 or 30 years. And to this day, we still have a lot of under and poorly ventilated buildings. In my firm, I promote increasing ventilation over that minimum standard by at least 30%. And when I've done that, I've found clients are really happy, but then I've got to be really creative because that can come with an energy penalty. So I have to do other things like energy recovery or other more complex technologies. But we're looking for that sweet spot of more fresh air and without having an energy or greenhouse gas emissions policy. And it's a big design challenge for all of us to get there. And again, we could go so much more, but the COVID thing is tough. Most buildings can't today increase the amount of fresh air, certainly not when we get to the dead of winter. They'll get too cold if we do. And yes, we're improving filtration, but the filtration is going to shorten the life of those systems because it's more drag on the motors. So there's some really tough decisions being made right now. My hope is that we're designing future buildings better and differently because of this experience. I'm working on an article on that. I hope to publish early next year, but it's a big issue. And our buildings haven't been healthy enough already, and COVID has exposed them, I think.
And I know that our members doing all sorts of projects are having these very conversations with their clients. It's just that the individual solutions are going to be, there aren't standards yet. There is how quickly does a client need something to be different? What kind of budget and time frame do they have? Are they doing a big remodel? Are they just trying to make their spaces incrementally better? Like it could be as simple as those contactless controls in restrooms and sort of stuff like that. So there's down to the level of individual devices that are going to make it healthier for the people that are in those existing spaces, up to rethinking office layouts for new projects because the open office has to be relooked at a little bit in a lot of cases from a health standpoint. So those big and small changes are happening on every part of every single conversation every architect is having with a client right now. We just don't have like the silver bullet of saying, if we just do this, we can fix everything. It's all patchwork and figuring out what's right for those individual clients.
Well, I trust all of you. So, well, you have all given up your Sunday for us, and I really, really appreciate it. It's small, but we're going to record it and we'll put it on.
I've been recording, and then I will get it to you as quickly as I can.
Yeah, I love this topic. This was something that was very new to me. So, and, so I got onto the other one that, and Jerry said, if you want to get on, let me know. So yes, yes, yes. So thank you, Jerry. Appreciate
Well,
it.
we're always excited to share. Thank you.
And thank you for all of you for giving up your time for us today. We really, really appreciate it. Thank you.
Yeah, so
It's our pleasure. Good luck on Tuesday.
Okay, Deborah. Thank
so
you.
interesting. Thank you so much.
Okay.
Thanks for attending.
Okay. Okay. Thanks, everybody.